Welcome to the Dapr community call. Thank you for joining us. Hoping everybody has been having a good summer so far. Excited to see you all. If you're new to the community call, welcome. We record these. They come out on our YouTube channel, so you can always catch up with old ones. During this call, we're going to have a few presentations, and feel free to, as I mentioned, put your comments or questions in the chat. We'll try to address them, and hopefully have enough time at the end to discuss anything you want, anything Dapr. So today, we have 3 topics, 3 presenters, Nick, Arthur, and Phil. Nick is gonna cover a really cool recent kind of Dapr integration with the bridge to Kubernetes, which, if you're not aware, is a really cool VS Code extension, and he's gonna show the whole thing. It's actually an awesome way to work and debug an application running on Kubernetes. Arthur is gonna cover scaling out actor reminders, and finally Phil is gonna present a proposal for pub sub message filters, and hopefully this can be a good discussion on that proposal and some feedback. And as always, please utilize GitHub and our Discord channel to continue these discussions moving forward. Yeah, with that, let's just get rolling. So I'm going to stop sharing, and Nick, take it away.
Cool. Thanks, Rory. And everyone see my screen? I should say Bridge to Kubernetes.
We see it.
Okay. So yeah, we're going to talk about Bridge to Kubernetes, the development tool, and how you can use it to debug your microservice applications that are using Dapr. So first, what is Bridge to Kubernetes? So Bridge is an existing development tool that's for developers who are authoring microservice apps that target Kubernetes. It's a client-side tool that is offered as extensions that you can find in the VS Code marketplaces, as well as VS, and soon to be a CLI. And the value prop of Bridge is that it allows a developer or a subset of the development team to work on a microservice or multiple microservices on their dev workstation, but connecting that workstation to a Kubernetes cluster where the rest of that application and services are running. So it allows you to work on 1 or 2 services on your machine, connect to a cluster where the rest of the app is running, and that way you can develop and test your changes end to end. And so this is a really good solution for when your app is comprised of many services and you just want to focus on this 1 or 2. And then you're also leveraging a lot of the technology such as Dapr from that deployed environment, from the Kubernetes cluster, where you don't actually have to run those things on your dev workstation. And as I mentioned, Bridge has been around for, it's been GA just short of a year now. And in their latest release, they just shipped support for microservice apps that are leveraging the Dapr framework. And so we'll jump into a quick high-level overview of what Bridge looks like, and then I'll show a demo of this in practice. So this is a microservice app that's running in Kubernetes. If you're familiar with any of the Dapr quick starts, this is the distributed calculator app. It's, like as I mentioned, architected as a microservice app. It's a polyglot app, and it functions as a calculator, a web app calculator. And as you can see, there's a front end. And then for each operation that this calculator supports, there's a microservice for each operation. So you can see the Go is the addition microservice, C# subtraction, Node division, Python multiplier. And so, there's many ways to work on an app that looks like this. You can run the entire application graph locally if you want. Bridge is just one tool that helps simplify that process. And so we know with microservice development, it's not uncommon for a developer or a subset of the development team to only work on one of these services or be responsible for one. So let's show that example here, right? So I'm a developer and I'm responsible, or I have a feature that I need to work on that's just in this one microservice, the node division service. And so in order to use Bridge, the first thing that I have to do is open the source code for that microservice in my editor. And so in this case, Visual Studio Code. And I would install the VS Code extension for Bridge to Kubernetes. And once I have this extension installed, I can now configure and have Bridge can make that connection between my dev workstation and my Kubernetes cluster. And so the first thing that it does is it shows you a list of services running in your cluster. And this is based off your kube config, your current context, which I'll show in a moment in practice. But once I have that list of services that I want to take over, so in this case, I would say I want to actually replace that running node service in my Kubernetes cluster with the one that I have running on my development workstation. And so what Bridge will actually do is it will go off and put the Bridge agent, you can think of this as like a redirector in place of that node service running in the cluster. So that when anytime a request is made, so in this case, let's say I hit the front end of my calculator running in my Kubernetes cluster, whether it's in Azure or a local cluster in my machine, and I perform a division operation, that request is going to be reverse proxied to my instance of that service running on my dev workstation, where my code changes and breakpoints will be executed and then sent seamlessly back into the cluster to be completed. So if I have other services in the chain of requests, it actually will send that request back, and that request will be completed. And so you can kind of think of this as, almost taking my workstation and putting it into that cluster environment, right? And so I only have this one source code running for this one service on my machine, but connection strings and everything else that is needed from that Kubernetes environment is inherited and available to this process running on my dev workstation. So you can see how it really simplifies the development environment, where I only have the source code, I'm only running this one service, but yeah, I'm still able to test my changes in the context of this entire app with this hybrid approach of sending traffic to and from the cluster. So let's take a quick look at how this works in practice, and I'll actually show this exact example here. So first, starting off with our sample app here, this is that calculator, and so I can say 8 divided by 4, 2, right? Works as expected. And so jumping into my VS Code, I have the Bridge to Kubernetes extension already installed. Again, you can find this in the marketplace. I have my current context set. So this is my Bridge cluster Dapr. This is my AKS cluster running in Azure. And I'm currently targeting the namespace of where my app is deployed to. And I have the source code open for that node service. This is it. This is all that it consists of, right? So here it is, the division operation. And so since I have Bridge already installed, I can use it to configure that connection between my workstation and my Kubernetes cluster. So the first thing you would do is you would go to Bridge to Kubernetes configure. And this is a 4-step wizard. It is persisted, so it's kind of a one-time setup unless you need to go back and change it later. And so what this is doing is actually looking at my current context, and it's making that request to my cluster and say, hey, what are all the available services that you have? And which one do you want to redirect to your machine? And so since I have that node service open, which I know is the division service, that's the service that I'm going to select. It's at this point, it's asking me, which port do you run this service on your development workstation? And so right here, you actually can see I have port 4000 in my source code. So I'm going to tell Bridge, I run this service locally on port 4000. The next question is, how do you run your service? So the idea behind this is if you've already customized how you run your service, NPM, node, whatever it might be, you can continue doing that, and Bridge will add some extra configuration from the cluster. If you don't have debug profiles available, this is a debug profile within VS Code, the VS Code folder that I've defined. You can always skip this and say, I'll just handle the connection part. I'll run my service how I normally would, whether it's in the term, iTerms, running npm rum, whatever. But for the sake of this, I have a launch profile already set up for me. And so I'm going to select that, and you'll see how that comes into play in a moment. And then the last question, this is not yet supported with Dapr apps, but this is an isolation mode where it's, if I'm redirecting traffic to my machine, you can see that if I'm working in a shared environment with other developers working in that same namespace, potentially on the same services that I'm working on, there could be some overlap with routing traffic to each other's machines. And so Bridge offers the option of isolating your requests. So only requests coming from your machine will get redirected to your source code on your machine, and so on for the other developers. So again, this is not yet supported as of today for any Dapr apps. So what we're going to select no. I'm also working in my own cluster in my own environment, so I do not need that isolation mode. And that's it. So at this point, Bridge to Kubernetes is configured, and I'm able to run my service. So I will put a breakpoint here, and I will go over to how I launch my service. And this is where I selected that launch profile. This is my existing launch profile that I can use when I run everything locally. But now I have this cloned version that Bridge created for me, which, as I mentioned, it's basically it'll do the same thing. It'll run my service, but it'll add some additional configuration from the Kubernetes environment. And so at this point, I'll hit play and run my service. And so what Bridge is doing is going off to my target cluster, finding the namespace, finding the service that I actually want to replace, and creating that connection. So you can see redirecting Kubernetes service divide app Dapr to your machine. It's validating credentials. It usually takes just a couple seconds. And there you go. And so my service is now running, and I can interact with my app as I normally would. So if we go back here and I clear this, right, I can now say like 8 + 2, right? Everything works as expected. I'm interacting with my app running and all the services running in Kubernetes. And so now if I said 8 divided by 4, you can see it just automatically flipped to my source code where my breakpoint was actually executed, and where I'm able to debug and look and inspect and make some changes on the fly and see those changes reflected. And so I can play through this, and then that request is completed. And so this is just a quick, and so the key here is I'm only running this one service, right? I'm not running it in a container, I'm running it natively. But yet I still have the ability to plug into that cluster environment and leverage all those other dependencies from that environment that allows me to test my changes end to end and see the impact that these changes have across the entire app. So I'll stop this, and what I will do is I will switch my current context just quickly for just to show that this can actually work not only on a remote cluster, but also a local cluster. And so, I already configured this. What I'll do is I'll just hit play. So at this point, I'm actually targeting my Docker Kubernetes cluster that I have running on my workstation. And this is just saying, when you configured Bridge, you were targeting a different cluster. Are you sure that this service exists in this new context? And I'll just say, yeah, I have the same app deployed to my local cluster instead of my Azure cluster. So again, finding that service, redirecting it to my machine, from my machine. And there you go. And so now if I go here and I actually go to localhost and say 8 by 4, my breakpoints hit. So I was able to just switch context that easily, right? And so yeah, this is the Bridge in a nutshell. You can see how, again, I'm not running much locally. It really helps reduce that development environment. It really simplifies that and allows you to just tap into the deployed environment. You can see how it provides a lot of fidelity, since I'm leveraging almost 90%, if not more, from the cluster environment. That's it. I think awesome. Someone jump in if I'm forgetting anything or if there's any questions.
So thank you, Nick. There's actually quite a few questions. Okay. I think, Mr. Jenks, maybe I'll just let you unmute, because it sounds like you might have a scenario where find you that you were kind of considering maybe using this.
Sure, and I will not make the mistake I made last time of remuting myself to be polite, because we have to go through the whole thing. So you can hear me breathe. Okay, I have a couple. Most of my questions about Dapperized stuff and microservices, and also about shared environments. So first off, this doesn't help if I have Dapperized services that are communicating to each other, whether they're using HTTPS or whether they're using events, right? This only redirects the HTTP traffic that's coming into that's coming into the pod, not stuff that's happening between the sidecar and the app. Is that correct?
I believe so. We also have Dan and Lorenzo from the bridge team, or the engineering team in the call, I believe, who could.
Okay, so if I have two microservices, A and B, that are cooperating,
Yep.
and they're using Dapr, either they're sending events or they're using Dapr's a service invocation, and they're sending messages to their sidecars, and then their sidecars are sending messages to them. That doesn't hit the bridge to Kubernetes interceptors, right?
So Daniel, you should be able to unmute if you want to take this question.
Thank you. Could you please also unmute Lorenzo, who was working on Dapr and might have even more information than I do about that. I think I can answer that, but I think Lorenzo will have even more context. Lorenzo, can you unmute now?
1 sec.
Yeah, can you hear me?
Yep.
Awesome. So actually going back to what actually happens with the traffic, we do not intercept the traffic at the pod level. We intercept the traffic at the container level. So basically we replace the container that is running the user code and we put our agent in there, but our agent is still talking to the Dapr sidecar. So the incoming traffic to your service running locally on your box is the one that you receive from the Dapr sidecar that will send it to your container that is running in the cluster.
So if I have two components that are using their sidecars to communicate,
yeah,
this will intercept that?
Yes.
So because it's intercepting the HTTP or gRPC. I mean, don't the sidecars use gRPC to communicate one to the other?
We intercept at the TCP level. So everything that lives on top of TCP is good for us.
Okay, so it would intercept my inter-service communication.
Well,
yes.
Is that true?
No, it's intercepting between specifically your app and the Dapr API, not between the two Dapr sidecars, right? Is that
correct? Yes. Yes. Yeah. Basically, you can imagine putting your development box instead of the container that was running your code with the Dapr sidecar on the side. The Dapr sidecar still stays there, and so your code is running localhost port 3500 API, Dapr API, and that call gets intercepted, send it to our agent, that contacts the Dapr sidecar that is running in the
sidecars, but it's in my container. The sidecar is in my container, so it's going to
No, the sidecar is a different container.
It's a separate container.
Oh, sidecar is a different container in the node. Okay, it's in my node. All right, got it. Okay, all right, cool. I was worried about that. Second question, this does presuppose that you have an environment out there that's running that has all of your data and all of your microservices.
Correct. Yeah, that is the prerequisite to using Bridge, is that your application is already deployed and running in a Kubernetes environment.
Okay, and furthermore, I wouldn't do this against production.
No,
you're assuming I have a non-production environment which has all of the appropriate data and all of the appropriate microservices set up and running in it.
Correct. Yes.
Okay.
Yeah, ideally you will have some kind of CI/CD pipeline that replicates what you usually have in production, but on a smaller scale cluster, and is your dev environment.
We're making this difficult because we're trying to get rid of those entirely and not have a single integration environment anywhere in our entire CI/CD system using Pact in order to make that happen. But that's a whole other conversation.
But you can still use it if a developer just wants to test his stuff.
What would they test against?
Well, sometimes there are people who spin up like very small clusters just for testing or for like a specific like once a day or once a week or something, or you can have a local one like kind or like something like that. So
the bottom line, I think, is that this doesn't work with my plans for Pact. This doesn't work for my plans to get rid of integration environments, because it just creates the burden for someone to have to maintain even a small secondary environment, and I want to get rid of those. But it is going to work with Dapr stuff generally, because it is going to intercept my sidecar, the stuff my sidecar is sending to me, whether it's gRPC or HTTP. Right.
So you I mean, the way I look at Bridge is more like, okay, I have an application composed of many microservices and I want to debug one, right? So one way to do that is just you have a Docker compose and spin up all the microservices locally, and you use container tools and you debug one. Another way is having some environment where you deploy the whole application, and then you want to debug only one service, but let the other microservices run in that environment. If you do not want to spin up a Kubernetes cluster for that, you can have a Minikube cluster locally, and you spin up all your microservices in your
right. That's assuming we have way too many microservices for that. But one other question: I know that Kubernetes has the ability to have a user-specific redirection, where you say, I want everything that's associated with Alice to come to my box and everything else to continue on in the shared environment.
But that doesn't work. That doesn't work with Dapr because for now with Dapr we do not. So Bridge to Kubernetes has this isolation function, but it's not available for Dapr yet.
I understand. Okay, that was the last thing I wanted to check on. All right, thank you. You've answered all my questions.
Okay, so we do have a few more topics, but I do want to address maybe a couple more questions that came up. I know Xavier asked, how is this different from VS Code remote containers? And what about TypeScript to JS compilers? Wouldn't they then show compiled code running on the Kubernetes cluster?
Okay, so this is fundamentally different from the remote debugger because the technology is different, right? When you have a remote debugger, usually you have your code running inside the cluster and you just attach a debugger to it, right? Like with Bridge, the technological approach is different because fundamentally your code is running locally on your local machine and we redirect the traffic from your cluster to your local machine. So this approach has some drawbacks, but it also big advantages, right? Like typically the fact that it's much quicker and that, once you're connected to the cluster, running your service is just running something locally. So so to give a short answer, this provides a similar feature as remote debugging, but the technological approach is different and we believe it's better.
Okay, and I saw there was another question on, does it always take a few, Jonathan asked, does it always take a few seconds to start Bridge or is it just during cold boot first time?
Yeah, so a few seconds is accurate. It does have a process that runs in the background that does take a little bit longer, I would, just from my experience. But I mean, you're looking at 20 seconds max, but subsequent connections should be faster as long as this process will continue to run. And if once it idles for longer than 15 minutes, I believe, then it will shut that process down and then you'll go back to having to warm up. But with that said, no longer than like 20 seconds. And what we see a lot of customers doing is it's more of a long-term connection. You don't have to restart unless you're making like configuration changes that you need to restart your debugger. You can actually set Bridge to persist that connection when you stop your debugger. So you don't have to continuously make that connection. You can restart your debugger and that connection will persist. That's just a way to customize it. So we see customers keeping that connection for a long period of time until they're done redirecting traffic, and then they'll disconnect. So hopefully that answers.
Okay. Cool. I'm sorry, I have to cut this short right now. Please, loving all the questions. Please continue on Discord and check out Bridge to Kubernetes. As Nick mentioned, the bits that actually support Dapr are actually out on the recent release. So we just use it. It should work, and we'd love to see your feedback and what you're doing with it. Archer, do you want to take on the next subject?
Yes. Can you hear me?
Yep.
Okay, so let me share my screen.
Can also see you.
Okay, good.
And your screen.
Okay, awesome. Okay. So do you have the PowerPoint ready?
I got the PowerPoint if you need to. Do you want me to show that first, or?
Yeah, it's going to show the PowerPoint first so people can have some context.
Yeah, 1 second, please. Let me share.
Okay. Yeah.
So let's go.
Go to scaling out. We
gotta
go back.
Whoop. Yeah, sorry. That was too much.
Okay, thank you. So yeah, we're going to scale out, explain how we scale out the storage of actor reminders in Dapr. So that will go a little bit deeper into how Dapr operates. Some level details for folks that are interested. Can you go next? Yeah, okay. So today in Dapr, every sidecar that uses actors with reminders will actually write to a single record on the database to list every single reminder. So there is a list that contains for every actor type, every actor ID, and every reminder name combination. It puts an item in a list that is saved in the state store. And the reason why this is done this way is because we don't support queries on the state store APIs. And also we want to make sure that there is some consistency when we read. So we keep all that in the same record. So as you can imagine, there are at least two problems with this approach. The first problem is that it can cause some delay on creating a reminder because it will require to write this record. And if there's multiple writes happening in parallel, that can be a race condition. So we fixed that a while back by using e-tag. So the e-tag is required for this write to succeed to avoid a race condition. But it's still, there's another problem that can actually happen, which is the size of this record can be so big that it cannot be written to the state store anymore. So it depends on the state store you use. There might be a max size limitation on the size of a record. So can you go next to the next one, please? So how we fix that? So we implemented in Sidecar for 1.3 a feature that will automatically migrate the existing solution into the new I would call scalable solution. And I'm going to go into detail in the next slide, but if you enable this, which is an experimental feature in 1.3, you can get Dapr to automatically split all your reminders across multiple records. And then you might ask, oh, but why not using the query state API? So we want to have finer control on this. So we want to make sure that that the list is actually self-contained, that we don't need to go and query and have like eventual consistency or pagination when we're reading in a query state. So this is a feature that we implemented for actors, and it can work for any state source, regardless of the query API or not. So we want to make sure we have that distinction of not using query. So how does this work? So we have a new record that is called the metadata record. So this record is an extensible record that can be used for persisting any information about an actor type. And we made this extensible because you might be able to use this for other features later on. So today, there's only one attribute in this metadata, one information, which is the actor reminders metadata. So, and today we put the partition count. In this case, in this example, it's 3. And we have an identifier. And the identifier here is very important because the identifier is what let us deal with the race condition where there are multiple Dapr sidecars run in parallel, try to migrate data or update your configuration in parallel. So the ID is what defines which metadata is actually valid. And in this case, we have a reminder partition, which we save as a separate record. So the identifier is part of the key, and then we partition that into, in this case, 3 different records. And each one of those has a subset of the list. And in this case, it's not a list anymore, it's a set, which means the order doesn't matter. So we evenly distribute the items across those 3 different records. So that is that is the approach that we took now to say, how do we now can have multiple records scaling the actor reminders across multiple records, so we don't have the limitation of the database, and we can also fix the partitioning problem. The performance problem when there are multiple writes on the same record. So now we only write the record that is modified. We don't write the others. And one more thing I'd like to mention is that this also enables you to change your configuration. So number partition is 3, and if you hit a limitation with 3, you can change to 5, to 10, and then Dapr will automatically reshuffle everything and write a new metadata ID. So this is how we are saving Dapr metadata, so Dapr reminders going forward. We are saving that splitting across multiple records, and we're also enabling configuration change. There's one thing that I like to call out is that we don't support changes going down. And the reason why is because if you have multiple versions of Dapr running, or at least Dapr configuration running, you want to make sure that you know which one has to win the migration. Otherwise, one might change your partition count from 3 to 5, and another sidecar might change from 5 to 3. So you don't want this like migration back and forth happening. So we allow only one-way upgrades. So that was a way for us to simplify the design and remove the ambiguity when you are rolling change in production. So and again, this is experimental. We are not enabling this by default, and we want to make sure that folks run this for some time before we actually make it the default behavior. So can you go next? Okay, so I'm going to do a quick demo now. Now I can really share my screen. Okay, so I'm going to look at the configuration first, and the feature that we call actor type metadata. And the reason why it's not, I'm assuming you guys can see my screen, correct? And it's readable?
Yeah, we see it.
So type metadata, because this metadata can be used for anything and not just reminders, okay? So this is something that we were cautious about to make it extensible for other features in the future. So it's disabled for now, and I'm going to run this example that there's a new setting in the SDK called reminders storage for partitions. And this example allows you to make it configurable when you're running it. So we're going to run, but because the feature is disabled, setting this will not make a difference. Okay. So let me run this first, this example. So we're going to have an actor running. And then we're going to have a client that will basically register three reminders. Okay. Sorry, one reminder on 3 different actors. So let me run this. Okay, the example is done. And if I go back, you can see now the reminder is being triggered. Okay. And if I go here and I refresh my database, let me just move this out of the way for a second. If I refresh, you can see now the records that we have for actors. And you can see now, this is the old way, okay? This is how it works today. You can see all reminders are written in the same list. And this grows pretty quick, as you can see. So this is just 3. And then we have some records here for each reminder. So next is we're going to go into, now we're going to go and enable the feature, okay? So let me also run this one more time so I can add some more reminders. So it's running, okay? Now let me add 3 more. So every time I run this client, I get 3 more reminders. And here it is. Now you have 6 of those. And now let me make a change. Let me enable this feature. Let me shut this down. And let me enable this feature. Give me a second. There we go. Now I'm going to enable this to true. And when I run, it's running with, let me remove this warning. I'm going to run this with -R3. And this is just a flag that I added to my example here that we basically set the number of reminders to 3. Reminder partitions to 3. And as you run the sidecar, you will see some warnings. So it's migrating. So see this warning, migrating actor metadata record. So it's doing the migration because it detected a change in the metadata config for actor. And then once it's completed, it gives you a warning that it's completed and gives the ID. It starts with 601. So if I go now here and refresh my Redis state store, you can see how this is the old record that we don't need anymore. We don't delete for now. And here you can see the new record that only contains, does it expand? Give me a second, I cannot see. It only contains the ID 601 that you saw and the metadata configuration partition equals 3. Then you have other 3 records that actually contain the reminders. And as you can see, they are all split across somewhat even across 3 different records. And it's a set in this case, it's not a list anymore because again, the order doesn't matter for us. So, and I can make another run here and make this go into, let me move this one more time. I can make this run with 5. Okay, migration completed, the same warning. And then after I go here and I refresh, you can see how now I have a new metadata record for 5.4, partition count equals 5, and I have this the list now is split into 5 different partitions. And now each one of some of them might be empty because we don't have enough data. But as you can see how the reminders are reshuffled across 5 different records. Okay. And we don't delete this because we want to avoid various conditions where somebody might be reading from the old config while the new one is still be written. So garbage collecting this is not something that we handle right now. We want to understand, first of all, if it's safe and how often these changes happen. We don't expect this config settings to change very often. So we're not very worried about garbage collecting these records for now. So it's only when you change the partition count. And that's what I wanted to demo. So thanks. And do you have any questions in the chat?
I'm not seeing anything. But yeah, if anything comes up, hopefully we can do it at the end of the call or continue on Discord.
Okay, thank you very much.
So 1 second. Okay, so the next topic, pub sub filtering proposal. Take it away, Phil.
Hello, everyone. Like we said at the top of the call, we'd love your feedback on this proposal that we've put together. So it's for pub sub filtering. A couple folks have asked for this, so it's time to perhaps get into implementing it. Next slide. So real quickly going over the design goals, the way it was kind of framed in the issue almost makes it sound like you're filtering out messages that you don't necessarily, the application doesn't necessarily care about. We're kind of flipping that around a little bit, ever so slightly, to say, hey, look, there might be one condition to say that this is what the app cares about now, but there might be more conditions for other types of messages that the app cares about 10 days from now or 2 weeks from now, right? So we want to have it be able to do one or many different paths based on certain rules that we, for item number 2 there, want to express declaratively. And since Dapr has embraced the cloud event spec, we are first and foremost going to use that information. That's the whole point of that spec, is to be able to make use of it in a tool like Dapr to be able to say, hey, for this type of message with a dot type of something I expect, send it this way. And maybe send a different type coming in on the same broker to a different path, right? That's very common as your application begins to scale. However, we don't want to break anything that we've put in place so far. So obviously maintaining backward compatibility, especially for programmatic subscriptions, is paramount. And lastly, whatever changes we make in terms of how you configure this new approach, and where I think we need most of your feedback from the community, is this still something that people can grok, right? Is it easily understood? Next slide. So before we get into kind of how the configuration looks, and the way I've kind of done this is I've taken the developer's point of view and looked at it from like, what does the new YAML look like, or what does the new programmatic API look like? But before we get to that, we should probably talk about this thing called cell. So we talked about a design goal being declaratively expressing the conditions for which a message should go down a certain path, right? And so that's kind of just in general what I'm calling routing. Back in the server, I don't even want to say it almost, but back in the message bus days, like they call that content-based routing. But it turns out that there's this project called Cell, or Common Expression Language, from Google, that is exactly fit for this purpose. And it has libraries in Go and some other languages, and it's already battle tested. It is in products like Istio and Firebase. And I've used it on previous projects. And even lately, one of the things that's important too, to some degree, is performance. And I kind of did a benchmark using it against kind of one of the other very popular Go-based expression languages. And it's about 40% faster than that other one. So things are looking good for this particular project. It's got pretty robust documentation, and obviously it's kind of new, and it's only going to get better from here. So that's kind of the backdrop of a pretty big design choice, is to use this cell language as the declarative filtering mechanism, if you will. And next slide, we'll see it in action. So here we go. So I don't know if many folks are familiar with this approach. Maybe they're using the programmatic approach, but there is a way to create a configuration file today. On the left is how you do it today. And it's really simple. It's obviously following the Kubernetes style YAML syntax and structure. And you really just say pub sub name and topic and optional metadata, and the route to which your app, if it's HTTP, it'll send that message to. And that's basically it, right? And the programmatic API kind of does the same thing. Where we're going potentially and thinking about this for the routing-based approach kind of makes it so that route gets it was one route, now it can be many, right? And so that changes the structure enough that we wanted to introduce a V2 of the CRD or the YAML structure, right? And so if you look, the real difference is it goes from a singular route to plural route, so routes. And you can see cell in action there where it says match, right? So that is actually a cell expression, and event represents the cloud event object itself. And the dot type is just part of the cloud event specification. And you can use that to essentially interrogate the contents of that cloud event and route it to a particular path on your application. And all this is so that your application doesn't have to have too many different if then else type conditions inside of it. So you can define as many of these as you want. And that's basically the gist. We'll get into some finer details here at the end, but let's go to the next slide. and just a refresher on the programmatic subscription is, again, it looks very much like the YAML syntax where you define the same things, and you're just handling I don't show a gRPC example here, but this is the HTTP example. So for Dapr subscribe, you just, this is also showing it without an SDK, just so you see the raw data being passed back and forth, but you're basically returning the same kind of information in that YAML, right? So now the question becomes, how do we move to supporting multiple routes? And admittedly, it does become a little more complex, right? So you're kind of defining a nested structure inside here. But if you look, it's pretty much the same as how it looked in the YAML example. There's multiple routes. Each of them have a match that is a cell expression, and they have a path. And notice we kind of renamed it to path because if you really think about it, even inside the Dapr code, the variables are all called path. And so we took this opportunity to sort of tweak the nomenclature to be more accurate. So think of that as like URI or path into your HTTP application. And that's basically the programmatic change to take advantage of this feature. So let's go ahead and go to the next slide. This kind of all opens up a big question. So my hypothesis is that even though introducing routes is cool, most apps, maybe even 80–90% of apps may not need to take advantage of it, right? And so how do we still keep this very clear and simple for apps that only need single routes? And so I think for the programmatic side, that's really simple. I think we just keep it as is and keep it backward compatible. And for the declarative side, it gets a little trickier because we are changing the YAML structure. The route field is now gone in favor of the plural routes. And so now the question becomes, how do you actually declare just the default route if your application only has one route? And so I think, it's a fine-grained, very, small question, but it can have a big impact. Like we definitely want it to be very clear. And, two options there, not that it's only limited to two, but it could just be that you don't specify a match field and that just becomes assumed that that is your default route that all routes will take if another match doesn't match and return true and send it that way. Or we can have some sort of way of specifying the match, but there's some sort of value in there that explicitly says, hey, this is the default route, and we could do it that way. Or there could be, other nesting and other options altogether, but I didn't want to go too far with this example and definitely let the community kind of weigh in as to how to make this the most approachable. So hopefully the problem statement is pretty clear, and hopefully this is a feature that helps you. I think let's go to the next slide. I just want to give folks links, and I'll post them into the chat after this. But there's the proposal, and there's an experimental PR, if you will, that's just intended to kick the tires on the idea, look at cell, and see how hard it would be to actually go about doing this. And so feel free to weigh in there. And if any of this is insane and you want to tell me that directly, like there I am on Discord, go for it. And that is it.
Great, thank you, Phil. I think there's a comment there from, let me see the chat. From George Stevens. Please make default explicit and call it default route or something like that. Make no routes totally simple. Please, otherwise it looks great.
All right, that's good stuff. That chimes in on exactly what we need to know. I'm not sure I understand Jagar's question or comment. Modifying troubleshooting for filtering. So I guess in general, like how do you really know if your cell expression is doing what you expect, right? And I think that's a good question. And that's probably something we still need to take in account in the design.
So Jagar, you should be able to unmute.
So what my question is like, if we add a certain routes programmatically in real time when the applications are in production, certain applications, maybe because of bugs, might be missing certain messages. So if we can have some sort of troubleshooting of, why certain messages were missed, or why the application did not receive certain messages, that would be great for troubleshooting.
Yeah, I agree.
Makes sense?
Perhaps there's like some sort of debug mode flag for this particular thing that
Yeah.
will explicitly log when it filters out a message. There's also some bit in the code that, like, if a cloud event has expired, that it just it filters those out as well. So I think what you're talking about actually can kind of apply in other scenarios as well.
Yep.
Cool. Yeah, that's a great point.
Okay, so I'm not seeing any more questions. With that, I know we don't have a lot of time, just a few minutes. Any other issues or questions or topics that anybody wants to discuss? You can drop them in the chat. I've seen some additional comments, by the way, on the bridge discussion. So we can use another the reminder of this call to talk about that. Yeah, and Paul is making a good point. If you have any suggestions or requests for things to cover for the next call, that would be great. Even if you maybe want to propose, if you wrote a cool application with Dapr, we've done this before. We're always grateful for people who want to share what they're doing with Dapr and what's the use case. That's always great. Okay, so with that, I think we'll finish this call for today. Thank you so much for all the presenters for presenting. Thank you for joining, and hopefully we'll see you next time.